The reason, you guys, the reason why we do all the divergence tests, Justin, waiting for you. The reason why we do the convergence tests is right now. Shh. Your back is to me. Okay. Now, we do this for these, what this is called is a power series. The rest of this unit is all about power series. A Taylor polynomial is a power series. Remember what a series is, adding up the terms in a sequence, and guess what? These are all powers. That's why it's called a power series. And what we want to do, notice there's a variable in here. We want to find x values so that this will converge. We use the ratio test to do that. If x is 1, then you're just adding up c0 plus c1 plus c2. That doesn't converge, does it? Okay, and these constants, when we do the Taylor polynomials, we'll find different ways to figure out what they are sometimes. Depends on what we're trying to do. Those are called the coefficients of the series. So what I have to do is know those convergence tests to see where this is going to converge, and you'll see what happens, where we're going to actually use it. And that's the main reason for knowing them, except that on the multiple choice part of the exam, as you've now seen, okay, James, as you've now seen, that that they'll have just plain questions on series. Okay, so it won't just be the power series. Okay, sometimes it will converge, sometimes it won't. It depends on what C is. So the sum of the series is a function whose domain is a set of all x's for which the series converges. And this is a polynomial, an infinite one, but it's a polynomial. And what's nice about polynomials? They're easy to differentiate, aren't they? It's just the power rule. So easy. There's no holes, there's no gaps, there's nothing there that causes us problems, where we might have something else that would give us a problem. Okay, so remember this one. We did this one in the end of 8-4. Do you remember what that was? What kind of series is it? It's a power series, but it's a special one. Well, let's write out the terms. It's x to the 0 plus x to the first plus x to the second plus x to the third. Nobody recognizes it? How do you get from here to here? Multiply by x. It's geometric. It's a very special power series. So this is a geometric one. And we know it converges. Should we do the when first? If we know it converges when, what's the common ratio here? Okay, girls, what's the common ratio? Okay, because this is the heart of what we're doing. So we got to get this. What's A? 1. This will converge when the absolute value of x is what? Less than 1. And what does it converge to? So you just use that little formula, A over 1 minus r. So it's 1 over 1 minus x. And I graphed that for you last time. Should we graph it again? Because what this is saying, that provided my x's are between 1 and -1, the graph of this and the graph of this are the same. Those graphs are the same. And I did it, but you probably forgot. It's a little bit of time. So let's go ahead and graph it. And what we're going to do is we'll use the TI-84 because I have the updated version. If you do, you can also do that with this. Because we can put the summation in there. How many terms would you like to have in it? The only way it truly converges is to have an infinite number of terms. If I do that, we'll be here forever, right? So how many terms would you like? I can't have, 30 is too slow. 10's probably plenty. Okay, so it was 1. And you will have, by the way, you can do that on your own, but you will have memorized this power series. It's one in the list that you have to memorize. Oh, there's only 5 you have to know. E to the x sine of x, cosine of x, this one, and might be, I think there's another one. Okay, now for this other function, this is where I'm going to put my series in. No, that's a rational function, right? Let's zoom at 4. Got a big gap there at 1, right? You can't divide by 0. So let's go back in here, and we could limit our domain, but at first let's just do this. Now, if you have the new operating system, you can do this. Otherwise, you have to actually type in 1 plus x squared. But this is kind of cool because I can do this with the summation. There it is, 2. And I want to start with n. Is that alpha? Yes, it is. Except they can't see it. Oh, I'm looking at the wrong thing. K, L, M, N. Blah, blah. It's really hard to see. We're going to start at 0. And then you wanted to go up to what? 10? Might be kind of slow, but we'll try it. And then we'll do x to the n. I mean, this is the whole point of doing these things. Let's see. I have to do alpha log. And this is used in biomedical engineering. They use these power series to approximate things. So I said, a little bit of time. There it comes. And it only is equal to that function just between 1 and negative 1. I don't know why it's kind of stopped. I don't know, it does. There. So you can't even see the difference here, can you? No. Okay. Now, okay, you guys. Now this power series was centered at 0. Okay, guys, this is important because you won't get this. Okay, you weren't going to get this with the centering thing unless you listen. This is set. What I did is I created my power series around that point, and I haven't shown you how we're going to get with Taylor polynomials. But it doesn't work very well if I get far away from 0. But if I wanted a power series for over here, I could find one for over there, and that means I'm going to find a power series at this point, and I'm not sure where it will converge, or if it will converge. So I want to start at a different place other than 0. So it's sort of like a translation. It's all it is. We'll see more of it as we get going into the harder stuff. So that one is centered at A. So we're going to have something centered at A. By definition, that x minus a to the 0 power is equal to 1. Okay? Even when x is equal to a, because what is 0 to the 0 power? Yeah, it's an indeterminate because you could have any number to the 0 power is 1, but you also could say 0 to any power is what? 0. So since I don't know which one it is, it's indeterminate. So we will choose to make this x minus a to the 0 power equal to 1, even when x is equal to a. It's the definition. We have to figure out what our problems are. Okay, so here is one series. You want to do this with me, and we want to find out where this converges. Well, guess what test we have to use? The ratio test, because it has a factorial in there. So before, we didn't have any x's in there except for that x to the n. We're going to do the ratio test, and we'll find out where this converges. Because remember, the limit, as n goes to infinity, of a sub n plus 1 over a sub n, the absolute value that if it's less than 1, the series converges. If it's equal to 1, we don't know anything. And if it's greater than 1, it diverges. And 3 things are going to happen. It will converge on an interval. It could converge at a point. Or it could converge for everything. Or it might diverge. But hopefully I'm going to find x's that'll work. Okay, ready to do this one? Now you guys probably want to do it with me. There's a lot of algebra. A lot of algebra. So it's the limit. And we've done this before. Unless you didn't do section 8.4, then in which case you didn't. Do I need the absolute value? Matt? They're all positive terms. Do I need the absolute value? Okay. We'll put it in, because Matt said yes. And then this is x to the n plus 1. And then what are we going to do? We're going to divide by this one. So it's divided by n factorial, and then this is x to the n. I put an n plus 1 in here and an n plus 1 there. Divided by, I'm not doing derivative. And I want that. I want to see if I can find x values such that that ratio will be equal to 1, that limit. Okay, this one's not too bad to do. Okay, what's n plus 1 factorial? James? What's n plus 1 factorial? Yeah. Now we don't need the absolute values. We look at that and say everything's positive. That's correct. What's x to the n plus 1? It's x to the n times x. Oh, yes, I do need the absolute values. He was right. Why was he right? Because x could be negative, couldn't it? Yes, x could be negative, because remember, now we have variables. Okay, so I don't know if they're all positive. Okay, what's going to happen here? We're going to cancel a bunch of stuff. We're going to cancel this out, and I'm going to get the limit as n goes to infinity. It's n plus 1. I can't pull the x out, because it's in an absolute value, times x. That has to be less than 1. What x values will make that less than 1? Keep in mind that as n goes to infinity, this is becoming infinite. There's only one x value that will work. 0. So this only converges at a point. So this is equal to, this will be equal to the original series, but only at x equal to 0. So there's 3 things that can happen. They can converge just at a point. We basically say it's going to diverge for all x's except when you make it 0. That's all. You won't run into that. You could have an interval of convergence, or it might converge everywhere. Okay, you ready for the next one? And Matt was right. We have to do absolute value. Okay, when they ask you this on the exam, for what values of x does the series converge, at least write down the ratio test, because you get a point for knowing it's the ratio test. It's usually a 6-point problem. Okay. So it's the limit as n goes to infinity, and it's x minus 3 to the n plus 1 over n plus 1, right? Now we're going to divide, but we're going to multiply by the reciprocal of that. So that would be n over x minus 3 to the n. And some of you will see the algebra easier than others. I want that to be less than 1. Remember, now we have variables in there. I'm going to pick the x's, so it's going to be less than 1. This is going to give me an interval.
Matt, since you're so smart, well,
Yeah, let's... Okay, we need the absolute value now. And so let's rewrite this. This is x minus 3, Marcus, to the n times x minus 3. Are we okay with that? It's just properties of exponents. That's all you need to know about exponents. And now, what's going to go underneath that? Let's put the x minus 3 underneath that. X minus 3 to the n, I said that one. Times, and then n over n plus 1. Now, when you do the limit of a product, you can actually take the product to the limits. Actually, you can pull this absolute value of x minus 3 out. What's going to cancel? Yep, that's going to go. So I'm going to be left with the absolute value of x minus 3 times the limit. Do I need the absolute value on this one? I can put it there. Let me just put it there just to be safe. I'm going to get an inequality. What is that limit? Yeah, it's 1. So I get this inequality. Absolute value of x minus 3 has to be less than 1. So let's just look at it geometrically for a second. It says the distance away from 3 will be 1 unit. I don't know if you ever thought of it this way. It will converge provided I'm within 1 unit of 3. So it's going to converge between here and here. But the problem is, and we'll look at that, what happens at 4 and 2. I don't know. I'm going to figure it out. Sometimes they do. Those are the endpoints. Always test the endpoints, even if you test them wrong. Now, how do you solve that absolute value inequality? You can just do what I did. And by the way, I want to stay with the red. This is called the radius of convergence. Because they may ask for that, or they may ask for the interval. So if it's basically saying you've centered yourself at 3 and you're 1 unit to the right, 1 unit to the left. It won't converge anyplace else. And you can graph them if you want. I don't want to graph them. Okay, how do you solve that? X minus 3 is going to be between 1 and what? Negative 1. And then what do we do? Add 3 to both sides. And I'm going to get, or all sides I should say, I said that wrong. I'm going to get 2 is less than X is less than 4, which I did get geometrically. That's called my interval of convergence. Okay, it's the interval of convergence. And you can write it this way. But now we have to check the endpoints. Because the endpoints, if you look at your ratio test, let's look at the endpoints here in my ratio test. If I put in, let's put in 4, for instance. It took me a couple years to realize this. But if I put in 4 here in the ratio test, I get 4 minus 3 to the n plus 1 over n plus 1 times n over 4 minus 3 to the n. And I want to take that limit. What is that limit equal to? As n goes to infinity, this is n over n plus 1. It's what? It's 1. Remember what happens when that ratio test, we get 1? The ratio test fails, right? So you have to go back and do those convergence tests on the original one. But they're almost always going to be p-series or alternating series. They're going to be very easy. But you have to do that. So we have to check our endpoints. So I'm going to have to write this function down. So it's x minus 3 to the n over n factorial, right? Well, it's not that hard. Some get to be tricky, but they're not really that bad. Oh, it's just n. Okay. That would. That's what I do memorizing. Okay, so let's try n equal to 4. Then this looks like this. N is equal to 1 to infinity, and you get 4 minus 3 to the n over n. Anybody recognize that one? It's this. It's 1 over n, right? Which is, all you have to say is harmonic. You could say p-series too. That's it. It's almost always going to be something like this. Almost always. So it's going to be easy compared to those other ratio tests. Not ratio, the other divergence and convergence tests. Okay. Try. Let's try. Now let's try the other endpoint. In fact, on the exam, I would even label it endpoints because it's clear to the reader you're considering the endpoints. You get the point for considering the endpoints even if you do them wrong. So it's like 6 points. Remember differential equations where you had to always add the c, and if you didn't add c, you were done? Remember how you had to get all these first initial steps right for you to get all the points? It's the same thing here. I want to get all the as many points as possible. I'll try the endpoints. So what's the other one? 2, right? So we do this, and it's 2 minus 3 to the n over n. Yeah, I'm putting that in for x, right? So I'm going to put in 2 here, and I'm going to put in 4. And then we're just going to look at that series. And what is this series? N is equal to 1. What's 2 minus 3? Negative 1 to the n. Won't be absolutely convergent, but what's this? Alternating harmonic. You could also say alternating series tests. You see? Oh, that's not fun. Alternating harmonic series. Or you could say alternating series test. Doesn't matter. So this is much easier than what you've been doing. Right? That's not hard. Okay. Oh, yeah. So which one did it converge? That converged, right? I'm sorry, I forgot to finish the problem. So this converges. Make sure you tell them that. So the interval is from 2 to 4, but we can't include 4. Sometimes neither endpoint will work. Sometimes both endpoints will work. But the endpoints give you the 1 on the ratio test. And that's why you don't know. So that you need to practice with these so you feel comfortable when you go into the exam and you say, oh, that's just the ratio test. That's an easy 6 points. Hey, David? Okay, here's only, I've talked about it already. Series may converge only at that one point when this part here is 0, so x is equal to a. Okay, Kevin? Matt? It could converge everywhere. E to the x, I can find a power series, it converges everywhere. Which is actually pretty cool, because you can actually have a nice polynomial that's equal to e to the x. Have a nice polynomial that's equal to the sine of x, cosine of x. Okay, or it could be an interval of convergence. Absolute value of x minus a is less than r. Notice it's 1x. Can't be 2x. We'll have to figure out what to do with that. So, the radius of convergence, in this case, is 0. If it only converges at a point. If it converges everywhere, the radius of convergence is infinity. And if you have it within the interval here is less than r, then the radius of convergence is, that's just the r. There's your interval of convergence, and there's the radius of convergence. Okay. Oh, it's not 600. I don't know what page that chart's on. So let's try another one. The ratio test can be to determine the radius of convergence in most cases, not everyone. It always fails at the endpoints, so you have to check those by hand. So why don't you guys try this? I'm going to pause the recording and let you try it. I'm going to do the ratio test on this. So we have 2 problems for you to try. And we have 3 days to do it, so give yourself a half hour. The more you do, the better you're going to be. Okay. So let's get it set up. Yeah, we're going to do this. So it's the limit as n goes to infinity, the absolute value of a sub n plus 1 over a sub n. You won't get an interval of convergence. We want that to be less than 1. Equal to 1, we know nothing. So when we get it set up, what are you going to write? It's negative. Now, how am I going to do negative 3? Well, negative 3 is negative 1 times 3 to the n plus 1. Do you realize that you can rewrite that as negative 1 to the n plus 1 times 3 to the n plus 1? Is that okay? Jordan, is that okay? Negative 3 to the n plus 1 is negative 1 times 3, and you can distribute that exponent across multiplication. Not across addition, but you can across multiplication. And then this is x to the n plus 1 all over the square root of n plus 1 plus 1 times, and then I want the reciprocal of that, right? And the reciprocal of that is going to be square root of n plus 1 over negative 3 to the n. You're going to have to rewrite that, and x to the n is less than 1. So try it. Because of the main limit theorem, you can take the absolute value of 3x out, and it's times the limit of the square root of n plus 1 over n plus 2. They're not always nice like this, but this one is. What is that limit? 1. So now we get this. Absolute value of 3x is less than 1. Okay, guys? Is the radius of convergence 1?
Yes.
No. Because you have to have 1x to find that. Because what is this saying? I have the absolute value of 3x is less than 1. So 3x is between 1 and negative 1. And if I divide by 3, x is going to be between 1/3 and negative 1/3. What's the radius of convergence? 1/3. Okay, guys? Now for the hard part, the end point. And so I have this. I have to check the endpoints because the absolute value. Okay. So wait, what is this over? Oh, square root of n plus 1. Okay. So now we have to put in, should we try the x equals positive 1/3 or the negative 1/3? Doesn't really matter. Oh, then we'll try the negative. X equals negative 1/3. So it's the summation, negative 3 to the n, negative 1/3 to the n, over the square root of n plus 1. Do you guys know what to do with those? What's going to happen to the signs here when you multiply these? Because it's really this. It's negative 3 times negative 1/3 to the n. That's right. So this looks like the summation 1 over the square root of n plus 1. It's the p series. The limit of this does go to 0, but does this converge? No, because of the p is less than 1. It's the p series. Now, do you have to do all the comparison tests on this stuff? Because it looks like 1 over the square root of n, and this is smaller. You would have to do a limit comparison test if you want to be totally proper. And I have not had the opportunity to grade these problems, but my guess is this is probably sufficient. But if you want to do it totally correctly, you would have to do 1 over the square root of n plus 1, 1 over the square root of n, and take the limit. And you'll see that that limit is 1. It's not hard to do that. Yes. Okay. Now, in the other one, I have x is equal to positive 1/3. So it's the summation, negative 3 to the n times 1/3 to the n over the square root of n plus 1. Yeah, that's why it's 6 points. It's long. It's going to alternate in sign because this negative 3 to the n can be written as negative 1 to the n times 3 to the n. And so what are you going to do about this? Yeah, it cancels out. So I end up with this series, negative 1 to the n over the square root of n plus 1. Does that converge? By what test? And that's all you have to do. You don't have to say that decreases or the limit of that is 0. You just say it converges by the alternating series test. Only if the limit of, let me repeat the question because it's not going to be on the recording. Do alternating series always converge? They converge only when the limit of this sequence goes to 0 and this sequence, b sub n, is decreasing. And it's going to happen. It's just the way it's going to be. Boom. So it converges at the positive 1/3. Make sure you tell the reader that it converges there. Make sure your work is neat and readable so that there's no doubt about it. So what's the answer here? This is going to converge here. So the interval of convergence is going to go from negative 1/3 to 1/3. Tomorrow, we'll finish this because we're running out of time to finish it today, but you could do it with the next one. And we'll do it, my opener for tomorrow, that's all there is, and you'll have work time. And then you should have work time also on Thursday. And then we get to the really fun stuff. This is just the ratio test.
Man, I thought it was fun already.
8-6 is critical. You do that.
5 tests.
Oh, look, get your math done now and you'll be fine.